Number 32. So given the following information, determine which lines, if any, are parallel. If R in S is congruent to PSN, which two lines are parallel? What's the transversal? NS is the transversal. So what are the two lines? I would say it's the NP and RS. See that? Okay. Next one. If MRS, this angle, and RSN, this angle, are equal to 180, what two lines are parallel? MR, that's really MR used down here. MR and NS. Yep. Okay. Find the value of X so that A and B are parallel. And so what do I have? These are what kind of angles? Yeah, alternate exterior. Okay, so alternate exterior, if A and B are parallel, those two angles must be equal. So I just set these two expressions equal and solve. So this is 10x, and this is what? 2 divide by 10. And then simplify. Okay. Okay, find the distance between parallel lines. You guys good? Okay, first thing I'm going to do is graph both equations. First one, I start at 2, and I go down 1 over 4, down 1 over 4, 1, 2, 3, 4. All right? No? 1, 2, 3, 4. And then connect these. I better do this one a little better. I'm going to go up 1 over 4. 1, 2, 3, 4. The more accurate you can draw these, the easier it's going to be to find the distance between them. And the next one, I'm going to start at negative 9/4, which is 2 1/4. 2 1/4. And I'm going to go down 1 over 4. 1, 2, 3, 4. Down 1. Yes. And I'm going to go up 1 over 4. Somewhat parallel. Okay, what's the shortest distance between two parallel lines? What kind of distance is it? Like, would it be from here to here? Is that the shortest? Here to what? Perpendicular distance. Right? So the slope of this line is negative 1/4. What's the slope of a line perpendicular to both of these going to be? Positive 4. Okay? So I can start with any point. I'm going to just start with a y-intercept. I'm going to go up 4. Actually, I'm going to start with this one. I'm going to go down 4 over 1. And then draw this line. So I want to find the distance between these 2 points. That's going to be the shortest distance between the lines. I already know the y-intercept of this line. because I intentionally picked that point. Okay? And it is 2. So the equation of this line is going to be y equals 4x plus 2. Because the slope is the opposite inverse of this. And I picked this line, or picked that point. Okay? So I've got to figure out what this point is. Well, the fact that I had to do things by quarters on the graph, my graph is probably not very accurate. I tried to make my lines as straight as possible. I didn't have a ruler. Okay, so how could I figure out what the coordinate of this point is? How do you find this point? It's where the two lines intersect. How do I figure out that point algebraically? Nope. Once I get the point, I will use the distance formula to find the distance. I'm trying to figure out what this point is. What's that? Set the two lines equal to each other. Where those lines are equal to each other, that coordinate satisfies both lines. So one line is 4x plus 2. The other is negative 1/4 x minus 9/4. I'm going to set those equal to each other to find the point. How many of you like to deal in fractions? Me either. What's the easiest way to get rid of them? I could multiply both sides by a number that would get rid of the fraction. What number is it? 4. Multiply by the common denominator. Okay, so if I multiply by the common denominator, it's a lot easier. Okay, now I'm just going to solve. I'm going to do this without the... So add x, 17x, subtract 9. X is negative 1. Now how do I find y? Yeah, plug it in. I'm going to choose this equation because it's a little easier. Negative 1, 4 times negative 1 is negative 4 plus 2. So y is negative 2. So it was, in fact, negative 1, negative 2 is my graph. I just didn't trust it. But I just confirmed that the point of intersection happens to be at negative 1, negative 2. Now that I know this point, and I know this point, I use the distance formula. Okay? So you can choose either to use the distance formula or just draw that right triangle. Okay? If I draw a right triangle here, this distance is 1. This distance is 1, 2, 3, 4. So to find this distance, I just use Pythagorean's theorem. I square this, and I add those together. And that's equal to this distance squared. So x is the distance between these two lines is the square root of 17 units. Okay, you'll probably have one like this on the test, so understanding how to do it would be important. Okay. Graph line M, whose equation is negative 6x minus 3y equals 9. Then construct a perpendicular line through 3, 1 and find the distance. Okay, so if I'm going to graph it, what's the easiest way to graph when it's in standard form? Yeah, do the cover up. Find your x and y intercepts. Okay, so I'm going to just make this a little darker so I can tell where my axes are. When I cover up x, y is negative 3. So my y-intercept is negative 3. When I cover up y, x is negative 3/2. Okay, all I need is 2 points to graph a line. Okay, what's the slope of this line? How can I figure that out without putting it into slope-intercept form? There's a quick way to do it. When it's in standard form, what's the equation? Good. Negative a over b. This is a, this is b. right? Negative a, negative of a negative 6 is positive 6 over b. So my slope should be negative 2. I could go ahead and look at my line here and see if it goes over 2 up 1, over 2 up 1. It looks like it's pretty close. Slope is negative 2. So if I'm going to construct a perpendicular line through 3, 1, 1, 2, 3, 1, I could use the inverse of this, positive 1/2, right? Up 1 over 2, I could go down 1 over 2, down 1 over 2, down 1 over 2, etc. There's my perpendicular. So there's my first point, 3, 1. Just like the last problem, I've got to find this point of intersection. And again, my graph's not perfect. So in order to do it, I'm going to set the two equations equal. Well, I've got to figure out what the equation of this line is then. I know the slope, and I know a point. Right? I know the slope has to be the opposite inverse of this. And now I can plug this point in. So 1 equals 3/2 plus b. When I subtract 1.5 from 1, I have negative 1/2. So b is negative 1/2. So this is the equation of this line. And I have this equation. I probably should put that into slope-intercept form so I can set the two equal. So negative 6x minus 3y equals 9. I'm going to add 6x and divide by 3, negative 3. So negative 2x minus 3 is this equation in slope-intercept form. Everybody follow that? So I'm going to set this equal to find where the point of intersection is. Again, a trick to get rid of fractions, multiply everything by 2. And solve. 5x equals negative 5. So x is negative 1. My graph's a little off. 5x, negative 5. And then I plug that in. I'm going to just pick this one. So that's 2 minus 3, which is negative 1. So this point should be negative 1, negative 1 where they intersect. I did something wrong. But negative 1 is where they intersect. So I need to find the distance from negative 1 to 3, 1. So if I go negative 1 and 3, 1, that distance, if I draw my triangle, from negative 1 to 3 is 4 units, and from negative 1 to positive 1 is 2 units. So just use Pythagorean's theorem. 16 plus 4 is the square root of 20. So the distance from between those 2 points is the square root of 20. You could simplify that by taking the square root of 4 out and making it 2 square roots of 5, but I would accept square root of 20 at this point. Okay. We're going to go to 38. If ABC is isosceles, B is the vertex angle, AB is 20x minus 2, BC is 12x plus 30, and AC is 25x. Find x and the length of each side. Well, if it's isosceles, these two are equal. So I'm just going to set these two equal to each other. And solve. So I found x. Now I just have to plug it in. So AC is 100. This is an x. This side's 100. When I put x for 4 in here, that's 80 minus 2 is 78. Maybe? And this better be 78 because I set them equal. So 12 times 4 is 48 plus 30 is 78. So these two sides are 78 and this side is 100. All right. Find the length of the sides of a triangle with vertices at 0, 4. I cannot draw straight lines. Save my life today. 0, 4, 5, 4, and -3, -2. So there's my triangle. This length is pretty easy. It's 5 units. This one, if you choose the triangle method, this distance is 2. This is 6. So I take 4 plus 36 is 40, and then the square root. Or just use the distance formula. But that's how the distance formula is derived, is from the triangle using Pythagorean theorem. So either way, you're going to get the same answer. So this is the square root of 40, which can be reduced to 2 square roots of 10, because the square root of 40 is the square root of 4 times the square root of 10, and the square root of 4 is 2. Okay. I can do the same thing and draw a triangle from this point to this point. This side is 1, 2, 3, 4, 5, 6, 7. And this side is 2, 4, 6. So 49 plus 36 square root. 85. So that distance is the square root of 85. So now I found the distance of all 3 sides. Okay. Use the figure below to answer the following questions. Find the value of x. Well, these two added together are 180, right? I guess I'm going to write in red for a minute. – 11x minus 40 equals 180. 11x equals 140. X equals 140 over 11. It's kind of ugly. Did I do that wrong? Huh? Yeah, that's why I did it wrong. Thank you. 320. Still not much better. Yeah. I'm losing my mind. That's a lot better. Did I do that right?
Yes.
Okay, thanks. I feel better. Okay, that's a little better. X is 20. Okay, find the measure of angle 1. If angle 1 is 4x plus 10. Well, I just found x. Yep, angle 1 is 90. Now find angle 2. Well, we could do one of two things. These added together is equal to this exterior angle. It's the exterior angles theorem. Exterior angle theorem. So we know this is 90. And we know this is what? We put 20 in. 160 minus 30 is 130. So this must be 40. Okay. What am I doing here? The vertices of ABC are -1, 1, 4, 2, and 1, 5. The vertices of DEF are -1, -1, 4, -2, and 1, -5. Can I go scroll up at all? Of course not. Identify the congruence transformation. So how did I get from here to here? Did I rotate it? Did I reflect it? Yeah, I reflected it. Looks like it's reflected over the x-axis, right? They're just mirror images of each other. Okay. Determine whether these two are congruent. I'll go red again. 1, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4. And 3, 6. There's my first one. And my second one is -4, -5. 1, 2, 3, 4. 0, -3, and -2, -1. They look like they are. One way I could just confirm it, maybe even without having to use the distance formula, just kind of figure out how many up and over I had to get to this point. 1, 2, 3, 4 over 2. 1, 2, 3, 4 over 2. From this point to this point, I go over 2, down 2, over 2, down 2. Here I go down 2 over 4. So I could do it that way. And they are congruent. Okay, I could prove it one step further using the distance formula, finding the distance of all 6 sides and showing that it's the same distance. But what I just did is good enough. Okay. In the figure, must be on the next page, AC and FD are equal, AB and DE are parallel, AC and FD are parallel. Anytime, before I even look at the figure, anytime I'm given that 2 sides are parallel, I know I'm going to be using an angle, not a side. Because the fact that 2 sides are parallel tells me nothing about the length of the sides, but it does tell me that there's going to be something about an angle there. So I know when I'm choosing side, 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 angle, all of those, I'm not going to use side, side, side. Because one of my angles is going to be congruent because I was given that they're parallel. Does that make sense? So before I even look, I know it's not going to be this. But now let's look. So AB and DE are parallel, AC and FD are parallel. And what sides? AC and FD. So this and this are equal. So if these 2 sides are parallel, I know this angle and that angle are equal. Right? And if these 2 sides are parallel, I know this angle and that angle are equal. So now I've marked it up. Is it side, angle, angle, or angle, angle, side? Angle, angle, side. Mark the drawings up. It'll make it really easy. It'll just pop out to you. You'll know which one it is. Angle, angle, side. It's not side, angle, side because I only have one side that's congruent. So it's got to be angle, or angle, angle, side. And angle, angle, the side that's congruent has to be between the 2 angles, and it's not. Okay? Mark your diagrams up, and it'll just pop out at you which one it is. If you just try and do it in your head, you're going to confuse yourself. I have to mark them. If you guys aren't marking them, I don't know. If I have to do it, I would assume you would need to. But maybe that's just a bad assumption. Okay, complete this 2-column proof. ABC is an isosceles triangle. D is the midpoint. BD bisects ABC. So I'm going to go through this proof and what they've written, and I'm going to mark this up as I go. Okay? They say that ABC is isosceles. I don't have anything to mark yet. Now they say AB and CB are equal, congruent. So I'm going to mark that up. Then they say angle A and angle C are congruent. Why? Base angles theorem. Base angles theorem. Yep. If these are both equal, it's an isosceles triangle. The base angles theorem says in an isosceles triangle, the base angles are equal. So this is base angles theorem. Next, D is the midpoint given. Therefore, AD and CD are congruent. Midpoint theorem. Now they're saying the two triangles are congruent. Well, I only have really four choices. Side, angle, side, 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 angle, side, angle, 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 side. My fifth is the hypotenuse leg that you'll use predominantly when you have a right triangle that's given to you. We don't really, they didn't give that to us. We're not going to use that piece. So on those four. Well, from what I've written, it looks like side, angle, side. Okay? Draw up your figures. Mark them up so you can see. Okay? If you're ever proving two triangles are congruent, don't tell me it's CPCTC. When you're proving triangles are congruent, it's angle, angle, side, side, angle, side, angle, side, angle, side, side, side. And hypotenuse leg if you're using a right triangle. Okay? Don't ever say CPCTC when you're talking about proving two triangles are congruent. And that's what this asked. These two triangles are congruent because of side, angle, side. Once you prove the triangles are congruent, then you can prove the corresponding parts are congruent by CPCTC, which is what they do next. And then they finish the proof. They're just trying to prove that this is an angle bisector, and they did that by proving those two triangles were congruent, and then using CPCTC to prove this angle and this angle are equal. The only parts we had to fill in was the base angles theorem and the reason those two triangles were congruent. And that comes in here and here. Okay? So as you go through a proof, you're not having to write one. I'm not making you do that. I had to do those in geometry. We had to write them the whole, ton of proofs. Take what they give you and mark your diagram up. And from there, you'll be able to figure out what's missing and what you can use. If you just do it in your head, it's not going to work. All right. Next one. What kind of triangle is this? Equilateral. So equilateral triangles, we know all the sides are equal. So to solve this, I just need to pick two sides. I don't have to pick, we know all the angles are equal in an equilateral triangle, right? Equilateral triangles are also equiangular. What is one of those angles equal to then? 60. So all I have to do is set one of those angles equal to 60 and solve for x. Okay, don't add all three of these up and set them equal to 180. It works, but you just added a ton of work to yourself. Okay, take the shortcut, know your geometry enough to know that each angle is 60. So each one of these expressions must be equal to 60. Okay, I'll just pick 15x plus 15. I can't write. 15x equals 45, so x is 3. That's it. Next problem. A wood column is supported by 4 cables to form 4 triangles. Determine which postulate could be used to show that all triangles are congruent. They're already marked for me. Could I use side, angle, side? Trick question. What's the requirement to use side, angle, side? Yeah, this angle has to be completely between two sides. It's not. It goes side, nothing, angle, side. There's nothing called side, side, angle. Because if I do it in reverse order, it's angle, side, side, and that's a good way to remember. The abbreviation isn't a word you should say in school, so there's no acronym for that either. Okay? So my hint here, when I see triangles that have a right angle, hypotenuse leg, this is where you would use hypotenuse leg. As long as it's a right angle and the legs are congruent, one leg is all you need. This is the hypotenuse leg theorem. Okay, so that's the reason those 4 triangles are congruent. Okay, use the following information to find the measure. Polygon PQRS is similar to polygon MNOS. The measure of MNO is 80. They've already written that in. PQ is 18, they've written that. RS is 15, MS is 6, NO is 11, and RO is 7.5. So what is the scale factor? And it says PQRS to MNOS, so PQRS is going to go on top. MNOS goes on bottom. So I can just pick a side and then find its corresponding side in the other figure. So PQ is 18. Do I know this side? I don't. What do I know? I know this whole thing is 15. So what is this side? 7.5, because this is given to me. Right? So 7.5 is here. So I could write 15 over 7.5. My scale factor is 2 to 1. Okay. What's the perimeter of the small one? What's the shortcut, once you know the scale factor, defining the perimeter of two similar figures? Do I need to find all the sides of both? Well, am I given anything that helps me with the perimeter of the big one? I know this is 6, this is 7.5, this is 11. I guess I could just find this side. This is 2 to 1, right? I just said that? Yep. So that means this side must be 9. Now I do need to just add them up. If I knew the perimeter of the outside, all I would have to do is divide that perimeter by 2 to find the perimeter of the smaller one because of the scale factor. I wouldn't have to find all the sides of the small. But I wasn't given all the sides of the out, so of the bigger one. So I'm just going to add 9 plus 6 plus 7.5 plus 11, and that's my perimeter. Okay. All right, multiple choice. At Whitewater Junior High School, there are 360 students, 39 teachers. What's the ratio of students to each teacher? So students has to go on top. Teacher goes on bottom. And I must simplify. 13 goes into 36. Does it go in evenly? No. 10 goes in evenly. Does it go into 39? No. 3 goes into both. 3 goes into 360 120 times. 3 goes into 39 13 times. 120 to 13. Okay, make sure that you're putting the right thing on top or on the left side of your ratio. Solve each proportion. How do I solve proportions? Cross multiply. Making sure I distribute to both terms. So this is 20x plus 20 equals 14x minus 14. Subtract, and divide. So it's negative, what, 17 over 3? Okay, there are 84 boys in a freshman class of 146. Find the ratios of ratio of boys to girls. So first I need to figure out how many girls there are. 84 to 146. 62. Which is what? 42 to 31. Okay, and here each pair of the polygons is similar. Write a similarity statement and find x, the measures of the indicated sides, and the scale factor. So if these are similar, my similarity, I'm going to pick whatever order I want for the left. But now I've got to match up. So what's similar, what's congruent to D? C. And to E, B. And to F then is A. So there's my similarity statement. That's half the problem. It said write a similarity statement. Now to find x, I'm just going to set up proportions using this similarity statement. So if I know that DE is 6.3, that corresponds to CB, which is what I'm looking for. And now I'm going to have to write another one. I have DF. DF corresponds to CA, and I have CA. So DF and CA are corresponding. So 5.7 over 21.66. 7.6 doesn't correspond to anything with a number. It does correspond to this side, but that doesn't help me because I need something with both numbers. Okay, at this point, I just cross multiply and solve for x. Any issues with that? The important thing here is getting your similarity statement right, so you know which ratios you can use. Oh, and I have a choice, but that's okay. Even easier then. Determine whether each pair of triangles is similar. So how could I do this? Yeah, if it were similar, I would almost think like I would rotate this. So if that happens, I would say that 24 is to 8 as 27 is to 9. And is that true? Yeah. So now I will say DEF then is similar to CBA. Right? DEF. Well, I know. I'm going to have to rearrange them now. So DEF would be D is to C, E is to B, right? EDF is to B, C, A. Okay. Find x in the measures of the indicated parts. Okay, these are parallel lines. Are these similar triangles? Yeah, angle, angle. If they're parallel, I know this angle and this angle are equal. I know this angle and this angle are equal. And I even know those two are equal by vertical angles, right? So I've got all three angles equal. So I know they're similar. So what's the similarity statement here? If this angle goes to this, if I write this triangle as CBD, picking whatever letters I want to, well, C corresponds to A, B corresponds to itself, and then I have E. That's my similarity statement. I'm trying to find x. So EB, let's do this. CD and AE, which are these two, are in this proportion. And I know that BD and BE are the other two sides I can write the ratio with. So I would write 9x over 4x plus 3. And then cross multiply. And subtract. X is 3. Once I know x, what else do I have to find? EB. EB is 12 plus 3, 17, or 15, sorry. Which is this one? Okay, this one was later in chapter 7, where you have two triangles created similar by two parallel lines that go through it. So I can say, this is 6, right? So I could say 2x is to 4 as 6 is to 8. Which is what? X over 2 equals 3/4. 2 times 2 is 4. So this is 1.5. 3/2. And what else am I looking for? AB. If it's 3/2, that's what? 3 plus 4. I get 7. Did I do something wrong here? Anybody get this one? Two x's to 4 as 6's to 8. I get x to be 3/2. They want to know what, oh, AB. I was doing AC. Sorry. AB, 3/2 times 2 is 3. So it's this one. Okay. Determine whether QS and PT are parallel. If PQ is 18, QR is 6, RS is 12, and ST is 36. So is 6 over 18 equal to 12 over 36? Yes. So they are parallel. And PQ over QR is how they've written it. So this would have been 18 over 6, 36 over 12. So it's 3 to 1. So it's this one. I think. ST, no, it's this one. They're not different scale factors. Okay, find the perimeter. If they're similar, all I need to do is find the perimeter of this one, figure out the scale factor, and then use that scale factor to find the perimeter of the second. So the perimeter of this one is 2433. What's the scale factor? ABC, PQR. So QR and BC. Yep. So I would say 11 is to 6 as 33 is to the perimeter of the smaller one. All you have to do is set up a proportion. You don't have to find every side and add them up. And this proportion, when it's like this, a fast way to solve it instead of cross-multiplying is recognizing 11 times 3 is 33. 6 times 3 is what? 18. Perimeter is 18. Yeah. Okay, name all planes intersecting CDI. Well, this is a plane. CDI is a plane. It's on that right side. So the planes intersecting it are what? HGF, this bottom plane, ADI, this front plane, the top plane, ABC, and the back, well, not this one. All of them but the left side. Name all segments parallel to GF. GF is right here. So this segment's parallel, this is parallel, this is parallel. Skew to BC. BC is here. Skew. CD is not. CD intersects. But IH is skew. And FG is skew. What else? AF, yep, and DI. They don't intersect and they're not parallel. They're skew. And then last question. May have time, may not. Fran used a graphics program to reduce a digital image. The original dimensions of the image were 11 centimeters by 10. She used a scale factor of 0.6. She reduced it. Scale factor is going to be smaller, so I'm going to take this times 0.6, which should be this one. Okay. Recordings being posted to Canvas for both days if you want to watch them.
Thank you.
Uh-huh.